In the diagram, PQRS is a trapezium with PS is equal to 8 minus X. That's what PS is, 8 minus X. QR is equal to 2X minus 5. That's what QR is, 2X minus 5. And height, 2X minus 4. And so here we have the height right here, which is 2X minus 4. Give an expression in terms of X for the area of the trapezium and show that it simplifies to X squared plus X minus 6. And so here we have the formula for the area of a trapezium, and the area of a trapezium is going to be equal to a half A plus B multiplied by H. So the H is the height, all right? So this is the height, and A is this side on top, and B is the side at the bottom, all right? And so what we're gonna do is we're gonna write an expression for the area of the trapezium. Remember, the area of the trapezium is a half A plus B multiplied by H. Here, A is equal to 8 minus X, and we have that right here, that's what A is. B is equal to 2X minus 5 because it's at the bottom, right? That's what B is equal to. That's what B is equal to. And H is equal to 2X minus 4 because H is the height, right? 2X minus 4. And so what we're going to do is we're going to substitute. So A is 8 minus X. B is 2X minus 5. That's what B is. And H is 2X minus 4. That's what H is, right? 2X minus 4. And so we have to, we're going to group all of the like terms. So we have negative X, and we combine it with 2X. So we have a negative X plus 2X. And we bring all the numbers together. So we have 8, and we have a negative 5. So 8 minus 5, right? And we multiply that by H, and in this case, H is 2X minus 4. And so we have negative X plus 2X, and negative X plus 2X is simply X. And we have 8 minus 5, and 8 minus 5 is definitely 3. And so we have X plus 3. And we just put 2X minus 4, and we put that here. That's going to be H, 2X minus 4. Next, we have to simplify, right? So we say, okay, we take 1 over 2, right? We take 1 over 2, and we divide. So we have 1 divided by 2, and 1 divided by 2 is 0.5. And so we have 0.5 multiplied by X plus 3 and 2X minus 4. And so what we're going to do here is we're going to distribute. And so we say, we're going to multiply these two expressions. So we say X times 2X gives us what? That gives us 2X squared. Then we say X times negative 4 is going to be equal to negative 4X. Then we say 3 times 2X, and 3 times 2X is 6X. And then we say 3 times negative 4, and 3 times negative 4 is negative 12. All right, so we have, in brackets, we have 2X squared. We have, so in brackets, we have 2X squared. We have negative 4X. We have 6X, and we have negative 12. So we have to multiply all this by 0.5. And so we have 0.5 multiplied by, so we have 0.5 multiplied by 2X squared. And that gives us, okay, so I wrote it twice. We have 0.5 multiplied by, I don't have to write this line, yeah. This is it twice. I don't have to write that twice. Oh, it's not, it's twice. I'm sorry. I did something wrong. What I supposed to do is I'm supposed to show you that we have a negative 4X and we have positive X. We have a negative 4X and we have positive 6X. Again, we have a negative 4X and we have positive 6X. And negative 4X plus 6X is equal to positive 2X. And so that's why I have this line, right? So before we distribute, we simplify what's inside the bracket. Again, negative 4X plus 6X. And negative 4X plus 6X. And negative 4X plus 6X is equal to positive 2x. And now we distribute. We say 0.5 multiplied by 2x squared is going to be equal to 1x squared, or simply x squared. Let me say 0.5 or a half multiplied by 2, and that gives us 1, or I'm sorry, 0.5 multiplied by 2x, and that gives us 1x, or simply just x. And we have 0.5 multiplied by negative 12, and 0.5 multiplied by negative 12 gives us negative 6. And so we have x squared plus x minus 6. Again, we have x squared plus x minus 6, and that's the answer to this question. And so what we did, we show that the area of the trapezium, the expression for the area of the trapezium, can be simplified to x squared plus x minus 6. Okay, next they tell us that the area of the trapezium is 36 centimeters squared. Write an equation for the area and solve for x. So the area of the trapezium is algebraically is x squared plus x minus 6. And from a numerical standpoint, the area of a trapezium is 36 centimeters squared. So these two must be equal to each other because both of them are referring to the area of the trapezium. And so what we actually have is we have this 36, which we're going to send over the equal sign. When we send it over the equal sign, if it's a positive 36, it becomes a negative 36. And so we have x squared plus x minus 6 minus 36. Then we say negative 6 minus 36, and that gives us negative 42. And so we have x squared plus x minus 42 is equal to 0. And this right here is a quadratic equation. And so we use the quadratic equation formula. And so in general, the general form of a quadratic equation is ax squared plus bx is ax squared plus bx plus c is equal to 0, where a is equal to the coefficient of x squared. That's what a is. A is the coefficient of x squared. And the coefficient of x squared in this case is a 1. And so that's why a is 1. And then we have b. B is the coefficient of x. That's what b is, the coefficient of x. And the coefficient of x in this case is 1. So b is 1. And then we have c, right? C is the constant, right? C is the constant. That's the number that doesn't have, C is the constant that's just the number by itself without the x. And so c is going to be negative 42 in this case. That's what c is, negative 42, all right? So a is equal to 1, right? B is equal to 1. C is equal to negative 42. And so using these values, we're going to plug them into our formula to figure out what is the solution, what is the value of x. And so we have this formula. We substitute, we know that b is equal to 1, so we put 1 here. We put 1 here. We know that a is equal to 1, so we put 1 here and 1 here. And we know that c is equal to negative 42, so we put it right here. Next, we evaluate the expression that's in the square root. So 1 squared minus 4 times 1 times negative 42. That gives us 169. So we have the square root of 169. And we have negative 1. So we put negative 1. So we put negative 1 here. Plus or minus all over 2 times 1. 2 times 1 is 2. So x is equal to negative 1 plus or minus negative 1 plus or minus the square root of 169 all over 2. So let's do x positive. X positive just basically means that we're going to use a positive sign, right, in between these two digits, or in between these two terms. So we have negative 1 plus the square root of 169 divided by 2. And what is the square root of 169? Well, the square root of 169 is 13. And so we have x positive is equal to negative 1 plus 13, and negative 1 plus 13 is 12. So we have 12 divided by 12, and 12 divided by 12 is 6. Next, we are going to figure out what is x negative, and x negative just means that we're going to use a negative sign in between these two numbers. And so what is the square root of 169? The square root of 169 is 13. And so we have -1 minus 13, and -1 minus 13 is going to be -14. So we have a -14 divided by 2, and -14 divided by 2 is -7. And so we have that x is equal to 6 and x is equal to -7. All right, so, but here we're going to use the positive value for x. We're going to ignore the negative result for x. And we're only going to consider the positive value for x, because if we use the negative result, then that means that this side is going to be equal to a negative number, and you cannot have the side of a trapezium equaling a negative result. And so definitely we have to choose the positive result. So x is equal to 6, all right, 6 centimeters. Next, it says, thus calculate the height of the trapezium. Now, what's the height of the trapezium? The height of the trapezium is 2x minus 4. Again, 2x minus 4. All right, so that's the height, 2x minus 4. And so we have the substitute, we know what the value of x is. We know the value of x is 6. So we say 2 times 6 minus 4. And 2 times 6 is 12. So we have 12 minus 4. And 12 minus 4 is definitely 8. And so the height of the trapezium is 8 centimeters. And that's the answer to this particular question.